In the fast-evolving world of robotics, Tesla's Optimus Gen 3 humanoid robot stands as a groundbreaking achievement in both artificial intelligence and robotics. With Tesla's reputation for pushing the boundaries of technological innovation, Optimus Gen 3 takes humanoid robots to a new level, introducing advanced AI capabilities and cutting-edge features that enable real-time decision-making, human interaction, and autonomous task execution. In today's episode, we will dive into its vision capabilities enhanced by a 10x improvement and analyze its integration with Tesla's Dojo supercomputer, which powers its advanced processing abilities. Before we begin, please help us reach 20,000 subscribers. It would be a huge motivation for us to keep bringing you amazing episodes about Tesla humanoid robots and all the latest AI and EV innovations from Elon Musk. How has the AI functionality of the Tesla Optimus Gen 3 changed? At the heart of Tesla, Optimus Gen 3 is its revolutionary AI assistant. Tesla's focus on creating a robot that can think and adapt in real time is made possible through this powerful AI system, which is designed to handle a variety of tasks that demand immediate decision-making and environmental responsiveness. Unlike previous iterations of Tesla's humanoid robots, Optimus Gen 3 features an upgraded AI brain that can process massive amounts of data faster than its predecessors, thanks to the integration of Tesla's proprietary Dojo supercomputer. The most striking feature of the Optimus Gen 3 AI is its ability to make rapid decisions based on sensory inputs. This AI system is designed to learn from its environment and react to changes instantaneously. For example, in a factory setting, Optimus Gen 3 can identify an object on an assembly line, recognize its position, and decide the most efficient action to take, whether to pick up the object, inspect it, or move it along to the next phase of production. The AI's decision-making ability is a critical advantage for any industrial setting where quick adjustments are required. Tesla's Optimus Gen 3 AI assistant can also perform multiple tasks simultaneously, managing complex workflows and engaging with numerous sensors to create a dynamic understanding of its environment. This is particularly useful in industries such as healthcare, where Optimus Gen 3 can be tasked with assisting elderly patients, providing real-time feedback to caregivers, and even adjusting actions based on patients' physical needs or environmental changes. A key enhancement in Optimus Gen 3 is its vision system, which has received a major upgrade, increasing its human recognition capabilities by 10 times compared to earlier models. This advancement is made possible by a combination of improved camera systems and advanced image recognition software, both of which are fine-tuned to interpret complex visual information with high accuracy. Tesla Optimus Gen 3 uses multiple high-resolution cameras strategically placed around its body, giving it a 360-degree field of vision. This expanded sensory coverage enables the robot to navigate and interact with its environment more effectively, allowing it to detect objects and people in real time. The vision system is capable of distinguishing between various objects, understanding depth and spatial relationships, and even recognizing human gestures or facial expressions. This makes Optimus Gen 3 highly capable in environments where human interaction is frequent, such as retail stores, healthcare facilities, and homes. The 10x improvement in human recognition also means that Optimus Gen 3 can distinguish individuals in crowded settings, identifying people and their specific needs or requests. This is particularly valuable in industries like healthcare, where personalized care is essential. In such environments, the robot could detect changes in a patient's behavior, such as recognizing if they need assistance or identifying a fall, and respond accordingly. This enhanced vision capability is not only important for safety and operational efficiency, but also enables a new level of precision in everyday tasks. Whether it's sorting parts in a warehouse or assisting with home chores, Optimus Gen 3's improved visual accuracy ensures that it can perform a wide range of tasks without human supervision. Tesla's AI ecosystem has evolved, with one of the most significant advancements being the introduction of Grock, Tesla's next-generation AI assistant. This AI is designed to work seamlessly within Tesla's suite of vehicles and products, but it has also been integrated into Optimus Gen 3 to enhance its conversational abilities and decision-making prowess. Grock can interact with humans in a natural, intuitive manner, interpreting voice commands and adapting to various contexts. The integration of Grock with Optimus Gen 3 is not just about adding another layer of functionality. It's about creating a symbiotic relationship between Tesla's AI and its humanoid robot. Grock brings advanced natural language processing capabilities, enabling Optimus Gen 3 to communicate with humans as effectively as any personal assistant. This integration represents a significant leap in the human-robot interaction space, as previous AI versions were more limited in their conversational abilities and understanding of nuanced human instructions. While earlier versions of Tesla's AI focused primarily on performing specific tasks within predefined limits, Grock expands the scope of this interaction, allowing Optimus Gen 3 to learn from ongoing conversations, adjust its behavior, and perform tasks based on the context of the interaction. This makes Optimus Gen 3 far more adaptable and capable of engaging in human-centric tasks like customer service, healthcare assistance, or even personal aid. What are the real-world applications of the Optimus Gen 3 vision system? The vision capabilities of Tesla Optimus Gen 3 are expected to have wide-reaching applications across several industries. In manufacturing, for instance, Optimus Gen 3 could be used to inspect products on assembly lines, ensuring that each item meets quality standards. The robot's ability to quickly assess and identify defects in real time will help manufacturers reduce waste and improve production efficiency. In healthcare, the ability to recognize human faces and track their movements could make Optimus Gen 3 an invaluable assistant. The robot could provide elderly patients with personalized care, alerting medical staff when an emergency occurs or when a patient's condition changes. It could also assist in tasks such as delivering medication, monitoring vital signs, or even providing companionship for those who need it most. Moreover, in customer service, Optimus Gen 3's vision capabilities will allow it to interact with customers in a more personalized manner. Whether helping customers in retail stores, guiding them through airport terminals, or assisting with hotel check-ins, Optimus Gen 3 will be able to provide a higher level of service by recognizing individuals and responding to their specific needs. At the core of Tesla's ambitious AI and robotics endeavors is the Dojo supercomputer, which serves as the brain behind the AI operations of Optimus Gen 3. Dojo is a powerful machine learning supercomputer that Tesla uses to train its AI models, process large data sets, and refine the decision-making abilities of robots like Optimus Gen 3. It's the backbone of Tesla's AI ecosystem, enabling real-time data processing and ensuring that Optimus Gen 3 can handle complex tasks efficiently. The relationship between Optimus Gen 3 and Dojo is crucial in enhancing the robot's performance. As Tesla's AI models become more sophisticated, they require more computational power to function effectively. Dojo's ability to process vast amounts of data quickly is essential for ensuring that Optimus Gen 3 can react to its environment in real time. This allows Optimus Gen 3 to not only perform pre-programmed tasks, but also adapt to new situations and learn from its interactions, making it far more versatile than its predecessors. Tesla's Dojo supercomputer has undergone significant upgrades, particularly in its ability to handle large datasets and accelerate machine learning training. The Dojo system's performance is integral to Optimus Gen 3's success, as it supports the robot's advanced AI and vision capabilities by providing real-time data processing. With its massive computing power, Dojo enables Optimus Gen 3 to learn from the environment and adapt its actions based on continuous feedback. This dynamic learning process is what makes Tesla's humanoid robots so advanced. Rather than relying solely on pre-programmed instructions, Optimus Generation 3 can adjust its behavior based on what it experiences in real time, making it much more efficient and autonomous. Recent updates show that Optimus Gen 3 has moved beyond a futuristic vision and is rapidly approaching consumers. Elon Musk recently sparked a storm of speculation with a reveal of Optimus Gen 3, coming right after he dismissed the idea that Tesla bot was still limited to Gen 2 or Gen 2.5. Analysts and enthusiasts alike regard this version as a critical leap that could bring humanoid robots directly into everyday households. Tesla's message positions Optimus not as a gadget, but as a lifestyle-changing tool. The contrast with Optimus Gen 2 is striking. While Gen 2 impressed audiences with entertaining demonstrations, such as dancing, balancing an egg, and performing expressive motions, Optimus Gen 3 has entered the realm of practical utility. Demonstrations have shown it vacuuming floors, stirring food on the stove, and interacting seamlessly with kitchen appliances. Elon Musk has described the robot as a versatile companion, envisioning a machine that can clean the house, watch over children, mow lawns, walk pets, and eventually even assist in manufacturing or service industries. Musk has confirmed that thousands of Optimus units will roll off the production line by the end of 2025, with a long-term goal of reaching an annual output of 500,000 units by 2027 and 1 million units by 2029. If achieved, this would surpass the scale of Tesla's early electric vehicle production milestones, representing one of the fastest adoption curves for any consumer technology in history. A key innovation driving this ambition is the integration of Grock, the conversational AI developed by Musk's X.AI. Unlike conventional digital assistants, Grock allows users to customize Optimus's tone, personality, and communication style. More impressively, it equips the robot with the ability to detect and respond to emotional signals through facial expressions and behavior. This leap transforms Optimus from a passive tool into a socially aware household member. Expectations continue to rise as Musk reveals more details. Optimus Gen 3 will reportedly support over 40 languages at launch, offering natural human-like conversations, and it will be capable of learning skills from online videos in real time. A Tesla engineer has confirmed that the robot can interpret context and act intelligently, navigating cluttered environments, adapting cleaning routines to individual preferences, and even refining its approach based on user feedback. This learning by watching ability sets it apart from today's robots, which are limited to pre-programmed functions. On community forums, two aspects are generating particular buzz: the Grock integration and Tesla's 2026 mass production target. Together, these factors fuel speculation that Optimus Gen 3 could debut with a price point around $20,000, a disruptive figure compared to robots with far fewer capabilities. Current market alternatives often exceed $100,000 per unit and remain confined to industrial use, whereas Tesla is pushing for affordability and accessibility in every household. The latest demonstrations underscore Tesla's progress. Optimus Gen 3 was shown lifting trash bags, placing them in bins, wiping tables, tearing paper towels, stirring pots, vacuuming, opening cabinets, and pulling curtains. Previous trials revealed additional versatility: folding laundry, watering plants, pouring drinks, checking inventory, opening car trunks, playing with children, dancing with families, and organizing kitchens. Each task represents a significant step toward replacing multiple, specialized machines with one unified platform. What is perhaps most impressive is Tesla's development speed. In less than 2 years, Optimus has advanced from a prototype with limited motion to a robot capable of running an entire household on voice commands, gestures, and even facial recognition cues. For users with communication barriers, such as the elderly or individuals with disabilities, this multimodal interaction could be life-changing. The technical specifications reinforce its potential. The Gen 1 Optimus used a 52-volt, 2.3 kilowatt-hour battery, providing hours of continuous operation without constant recharging. Although Tesla has not yet disclosed detailed battery improvements for Gen 2 or Gen 3, the overall weight has dropped to 138 pounds, a 10% reduction, pointing toward higher energy efficiency. Optimus Gen 3 can carry loads of up to 45 pounds. With 26 degrees of freedom in its arms and finely tuned actuators, it demonstrates human-like dexterity, enabling it to handle delicate objects, operate vacuums, or prepare a full meal in minutes. Crucially, the robot grows more capable with use. Each task completed feeds into its continuous learning system, making the machine smarter and more efficient over time. Outdoors, it can handle basic gardening, trimming trees, watering plants, and fertilizing lawns. Musk has even claimed it could thread a needle, emphasizing the precision of its design. Beyond daily chores, Optimus is branching into education and healthcare. It can function as a home tutor, reading books aloud, assisting with schoolwork, or delivering lessons. For older adults, it offers critical support, helping with mobility, meals, bathing, and reminders to take medications. With Alzheimer's patients, for example, Optimus can track routines, recall important details, and alert caregivers when necessary. In emergencies, it can notify family members or authorities. In addition, the robot can take on DIY household tasks, such as changing light bulbs or fixing electrical sockets, giving it utility as both caregiver and handyman. What are the differences between Tesla Optimus Gen 3 and Figure AI Gen 2? While Optimus version 3 is making headlines, it is not entering the humanoid robot race alone. Another major competitor is Figure AI's humanoid robot, which has also demonstrated impressive capabilities in recent demonstrations. Both companies share the vision of creating general-purpose robots that can take on household, industrial, and service tasks, but their approaches and progress show clear differences. But how will Tesla manage to produce Optimus in just 5 seconds? What's the real production speed of Optimus Gen 3? Just imagine a factory where every 5 seconds a complete product rolls off the line. That number may sound insane, but it's exactly the pace Tesla has achieved in the auto industry, an industry notorious for its complexity. Elon Musk once shared that the total production cycle could be brought down to 10 seconds, and thanks to Tesla's unique assembly line design with minimal human intervention, on average, a new electric car rolls out every 5 seconds. This isn't just high efficiency, it's proof of how Tesla applies physics-based thinking and automation to redefine the very idea of mass production. Now, if we shift that logic to Optimus, the picture becomes even more fascinating. Current robotics companies like Boston Dynamics or Agility Robotics are only building a few hundred to a few thousand robots per year, mostly for research or pilot projects. Tesla, on the other hand, with experience producing over 5 million EVs and gigafactories spanning the US, China, and Europe, could realistically aim to turn humanoid robots from a rarity into an everyday product. With a line running at 5 seconds per robot, theoretical output could hit more than 6 million units a year. Even accounting for robots being more complex than cars, achieving just 10% of that efficiency would still put Tesla leagues ahead of any competitor. The key to making this scenario credible lies in Tesla's ability to reuse proven manufacturing breakthroughs from its EV business. The Gigapress, those 54,000-ton aluminum casting machines, reduced the Model Y's part count from over 170 separate components to just 2 giant castings. That simplification was what enabled Tesla's jaw-dropping production speed. For Optimus, Musk has hinted at a similar approach, designing the robot as a set of modules, arms, legs, torso, head, each mass-produced like car components, then assembled in a final stage. Standardization and modularity are the real levers that could transform millions of robots per year from a slogan into reality. Another striking factor, Tesla repeatedly emphasizes that its patents are open source. In other words, Musk isn't afraid of being copied. He believes the true advantage doesn't lie in blueprints, but in the ability to manufacture at scale. This is exactly how Optimus could replay the success story of the Model 3. While other robotics firms are still tinkering with pilot lines, Tesla already has the infrastructure, the automation, and most importantly, the culture of speed. Still, the burning question remains, can something as complex as a humanoid robot really be produced at a rate of 5 to 10 seconds like a car? The realistic answer is probably not right away, but history with Tesla shows a clear pattern. At first they're slow and expensive, then once optimized, both speed and cost fall exponentially. When the Model 3 first launched, Musk himself called it production hell. Yet just a few years later, it became the world's best-selling EV. If Optimus follows that trajectory, the early years may see only a few thousand units, but then growth could explode in true exponential fashion. And here's the most exciting part. High-speed production doesn't just help Tesla meet demand, it directly drives prices down. If each Optimus line can output hundreds of thousands to millions of robots annually, the sub-$20,000 price Musk has teased is no longer a fantasy. That means within a single decade, humanoid robots could become as common as motorcycles or smartphones, something ordinary people can own, not just experimental prototypes hidden away in labs. Once again, please help us reach 20,000 subscribers. This is important for us to stay motivated. Thank you. How do Optimus's complex design and impact its manufacturing process? Manufacturing an electric car is already a huge challenge, but compared to assembling a humanoid robot like Optimus, it almost seems simple. The reason is that an EV, despite having thousands of components, still operates in a relatively stable environment: roads, weather, and mainly indirect interaction with humans. Optimus, however, is entirely different. This is a machine that must live in the human world, walk on legs, use its hands to grasp objects, and above all, function in tight spaces such as kitchens, warehouses, or hospitals. The very fact that it needs to work closely alongside humans makes its production and testing far more complex than a car assembly line. Take the hands of Optimus Gen 3, for example. Tesla revealed that each hand has 22 degrees of freedom, meaning joints that can move independently to mimic the dexterity of human hands. This number far exceeds the 10 to 12 degrees of freedom typically found in industrial robots used for gripping objects. But 22 DOF is not just a vanity figure. Each DOF represents a motor, sensor, cable, and control circuit, adding up to dozens of microcomponents that must be assembled and precisely calibrated. According to robotics industry data, calibrating a single DOF with less than 0.1 millimeter of error takes 20 to 30 seconds when done manually. Multiplied across 22 DOF, calibrating just one hand takes more than 10 minutes, not including both hands and the tactile sensors. Meanwhile, Tesla's goal is to push Optimus down a line at EV-like speed, meaning tens of seconds per robot. This is clearly a serious bottleneck. And it doesn't stop at the hands. Optimus's entire body is a sensor matrix. Elon Musk has revealed the robot has more than 28 major joints, multiple wide-angle cameras, 3D LiDAR sensors, and an IMU system for balance. For comparison, a Tesla Model 3 only requires calibration of its autopilot cameras, 8 units, and a few radars, a process that can be automated in minutes. Optimus, in contrast, needs every sensor across its body to be synchronized, since even a minor error in gravity or angle sensing could cause it to stumble down a staircase. Research from Boston Dynamics shows that humanoid robots still fall at a rate of 2 to 3 times per operating hour, even under controlled conditions, with each fall risking damage to components worth thousands of dollars. This highlights how testing before delivery will be exponentially more complex and time-consuming than for cars. Another underestimated factor is safety standards for robots operating near humans. Cars have crash tests, airbags, and emergency braking systems, but drivers remain inside a cabin, providing a physical safety buffer. Optimus is different. It can stand right next to you in the kitchen, handle knives, carry boiling water, or even support an elderly person while walking. Every single error poses a direct injury risk. Therefore, before Optimus hits the market, Tesla must prove it meets entirely new safety benchmarks, far beyond ISO 10218, the standard for industrial robots. That's why companies like Agility Robotics have limited digits trials to Amazon warehouses instead of private homes. Tesla also faces supply chain bottlenecks due to Optimus's cutting-edge components. Take the new 4680 battery, which enables 48 hours of continuous operation, an impressive figure. Yet global 4680 output is still limited. Tesla estimates current capacity at only 30 to 40 gigawatt-hours per year, enough for a few 100,000 EVs, but nowhere near sufficient to support millions of robots, each requiring a 2 to 3 kilowatt-hour pack. If Optimus enters mass production, the battery, the robot's heart, may turn into the biggest choke point. Picture a production line at Giga Texas. On one side, massive Cybertrucks rolling out every 45 seconds. On the other, Optimus units with thousands of microparts demanding precision in both hardware and software. To match automotive speed, Tesla would have to reinvent the way robots are assembled, from attaching joints and wiring harnesses to calibrating sensors. And this is not just a technical issue, but also an economic one. If each robot requires 2 to 3 hours of testing before shipping, labor and infrastructure costs could easily add thousands of dollars, directly threatening Musk's promised less than $20,000 price tag. The software side poses another unique challenge. For EVs, Tesla can ship cars and gradually improve them with OTA updates. But for Optimus, a bug in motion, say gripping a glass too tightly until it shatters, or miscalculating force while supporting an elderly person, could have immediate and unacceptable consequences. This means Tesla must rely on a massive simulation system capable of running millions of scenarios before releasing even a single update. The costs of such infrastructure will inevitably add to the overall expense of robot production. Taken as a whole, Optimus is not just a human-shaped machine, it is a complex integration of precision mechanics, sensors, AI, safety systems, and supply chain logistics. Elon Musk once said, "Producing at scale is the hardest part." With Optimus, that statement rings truer than ever. To overcome these hurdles, Tesla will need more than just gigapresses and assembly robots. It will have to invent an entirely new system where each finger joint is auto-calibrated, every sensor verified by AI, and every 4,680 cell manufactured at a scale sufficient to power an army of humanoid robots. These unique challenges are what set Optimus apart from any EV Tesla has ever built. How ready is the market to adopt Optimus Gen 3? When we look at the current humanoid robot market, a striking paradox emerges. While technology has advanced tremendously, real-world demand remains modest, mainly because prices are too high and production capacity is extremely limited. Famous humanoids like Boston Dynamics Atlas or Agility Robotics Digit are still used mostly in labs, internal trials, or niche industrial applications, with very small production runs. Most robotics companies only dare to announce plans to build a few dozen or a few hundred units per year, and none have yet taken the bold step into true large-scale commercial production. So, what has changed to make this moment a window of opportunity for Tesla to launch Optimus Gen 3? At least three critical factors are converging: falling component costs, rising labor and automation pressures, and Tesla's mature manufacturing model. First, the cost of components and electronics has dropped significantly compared to 5 to 10 years ago. 3D sensors, high-resolution cameras, compact servo motors, integrated motor controllers, all have become more accessible. Many parts once reserved for aircraft or research robots can now be mass-produced at a fraction of the former cost. This lowers the entry barrier for building a humanoid robot. Tesla, in particular, can leverage its EV-scale component purchasing power to supply Optimus, letting its robotics division piggyback on the economies of scale already built for cars. Second, globally, labor shortages and automation needs are intensifying. In many countries, wages are rising, populations are aging, and minimum pay is increasing, making it less viable to hire humans for repetitive tasks like cleaning, assisting, packaging, or moving goods. If humanoid robots become smart and adaptable enough, they can fill this gap. Should Tesla release Optimus Gen 3 at an accessible price point, millions of households, hospitals, nursing homes, and hotels could become potential buyers. At that stage, demand would no longer be aspirational. It would be driven by hard labor market pressures forcing machines to replace humans. Third, Tesla enjoys a manufacturing advantage unlike any other. It does not have to start from zero. With over 5 million EVs on the road and gigafactories across the US, China, and Europe, Tesla has already built a robust foundation of production lines, supply chains for batteries and motors, and advanced automation systems. When Tesla announces Optimus Gen 3 production, it's not acting like a startup that must build everything from scratch, but as an industrial giant with capital, infrastructure, and expertise in place. It only needs to allocate part of its existing resources to integrate humanoid production. This allows Tesla to reach break-even far faster than traditional robotics companies ever could. Crucially, Genesis 3, the version Tesla promises, will bring major upgrades: stronger sensors, 22 degree of freedom hands, a higher energy 4680 battery, and the to operate for 48 hours continuously. It isn't just an experimental prototype, but a commercial product aimed directly at end users. Once Gen 3 arrives, customers will no longer have to buy overpriced demo robots just for testing. They'll be able to purchase reliable, functional robots at Tesla's target price point, around $20,000. When a product is good enough for mass market use, demand doesn't trickle, it surges, because buyers won't want to wait. One important indicator. In robotics, whenever a humanoid is released that's good enough, prototype orders typically skyrocket far beyond expectations. For instance, when Boston Dynamics launched spot trials in warehouses, they received unexpected small batch orders from logistics startups. That proved that once a robot is close enough to practical reality, no longer needing hours of repair after each task, buyers quickly appear. If Tesla achieves this with Gen 3, it could trigger a wave of demand the industry has never experienced. Finally, the relationship between production and demand forms a positive feedback loop. The more Tesla produces, the cheaper the robots get. The cheaper they get, the more people buy. The more people buy, the harder Tesla pushes production. This dynamic means Tesla is not only entering the perfect moment to launch Optimus Gen 3, but also positioned to move humanoid robotics from the experimental phase into true mass consumer adoption. And with its unmatched production power, Tesla stands as the strongest contender to make it happen. How will hardware strength compete with advanced language AI? In the humanoid robot race, technology is always seen as the beating heart that determines who comes out on top. And this is exactly where Tesla Optimus Gen 3 is showing clear progress compared not only to its predecessor Gen 2, but also to its main rival, Figure 02. While Gen 3 was more of a proof of concept, able to walk steadily, lift basic objects, and test some industrial tasks in controlled environments, Gen 3 has moved into a whole new phase, with a series of under-the-hood upgrades that go far beyond cosmetic changes. One of the most important differences lies in its battery system. Tesla has equipped Gen 3 with its next-generation 4680 battery pack, the same innovation that revolutionized its EV business. This pack allows the robot to operate continuously for up to 48 hours in standard working conditions, while Figure 02 currently claims only 4 to 8 hours depending on usage, on par with most humanoid robots on the market. The gap is massive, as it not only reflects Tesla's battery technology advantage, but also shows how effectively the company can leverage its established battery production ecosystem. Compared to Gen 3, which could only run about 8 to 10 hours before recharging, Gen 3 is a quantum leap forward, like comparing an old flip phone with a modern smartphone with ultra-long battery life. Beyond the battery, another major advancement lies in its processing brain. Optimus Gen 3 is powered by Tesla's latest generation FSD chip, originally designed for autonomous driving. This chip delivers up to 144 trillion operations per second, enabling the robot to process visual, audio, joint, and sensor data in real time. That gives Gen 3 smooth, human-like motion and the ability to react instantly to unexpected situations. In contrast, Figure 02 still relies on standard NVIDIA GPUs and some outsourced AI modules, which makes its hardware-software integration less seamless. Tesla's advantage is its vertically integrated ecosystem. Hardware, software, batteries, and AI training all exist in one closed loop. Compared to Generation 2, which used an older FSD chip and often showed half-second delays when responding to complex inputs, Gen 3 eliminates those weaknesses, making it capable of not only working but also blending into human workspaces naturally. Another technological milestone for Optimus Gen 3 is its machine learning system, directly connected to Tesla's Dojo supercomputer. Thanks to Dojo, thousands of Optimus units can learn simultaneously by sharing training data, improving skills exponentially. Elon Musk once compared this to a team of robots learning together rather than individually. Figure 02 also applies centralized training, but its computing infrastructure is nowhere near Dojo in scale or speed. This gives Tesla the ability to shorten the time it takes to roll out new skills. For instance, once a small batch of Optimus learns to stack goods in a warehouse, the update can be pushed over the air, OTA, to the entire fleet within days. Gen 2 also had OTA capability, but limited training data and weaker processing power made improvements much slower. That's why Gen 3 is already tackling advanced tasks like parts inspection, assembly line assistance, and material transport, while Generation 2 was mostly restricted to repetitive, simple actions. Sensor technology further highlights the difference. Tesla equipped Gen 3 with high-resolution cameras combined with fingertip force sensors, allowing it not only to see, but also to feel objects with high precision. This is crucial for delicate tasks such as electronics, assembly, or handling fragile items. Figure 02 boasts hands with 22 degrees of freedom, DOF, impressive on paper, but its control accuracy still needs to be validated. Tesla itself faced issues in Generation 2, where fingers often slipped or applied too much force. With Generation 3, those problems have been solved through improved force sensors and predictive AI models that calculate optimal grip strength. This brings Optimus Gen 3 closer than ever to replicating the dexterity of the human hand in production work. On the software side, Tesla also holds a commanding edge. Optimus Gen 3's AI operating system builds directly on years of autopilot and FSD development, tested across billions of real-world driving miles. Tesla has transferred this logic of navigating complex environments from cars to robots, only now the setting is factories, warehouses, and homes. Figure 2, by comparison, is still in early-stage software development, meaning it can perform certain pre-programmed tasks, but lacks deep contextual understanding. It's like comparing a student reciting memorized answers to a graduate who has learned through real-world experience. Gen 3 shared this limitation, but Gen 3 has finally crossed into the realm of adaptive intelligence, capable of learning, generalizing, and solving problems dynamically. Taken together, Tesla Optimus Gen 3 represents a tightly integrated technological package, from batteries to processors, from sensors to AI infrastructure, all built on more than a decade of Tesla's accumulated expertise. This gives Tesla an advantage that Figure 02 cannot realistically close in the short term. Gen 3 doesn't just surpass Gen 2 in durability, processing power, and dexterity, it also creates a wide gap with its main competitor. Such technological dominance is not only a strength for winning the humanoid robot race, but also the foundation for Tesla's long-term goal, scaling production to millions of robots serving across industries and households alike. The key question is no longer whether Tesla can achieve this, but how soon Optimus Gen 3 will prove its power in the real world, and when that happens, will rivals like Figure 02 be able to catch up with Tesla's breakneck pace of innovation? Once again, please help us reach 20,000 subscribers. This is important for us to stay motivated. Thank you. Who proves more capable in handling practical work, V3 or Figure 02? When it comes to the task-handling ability of humanoid robots, the most important measure is not the technical specifications or price tags, but how many real-world jobs a robot can actually perform. Tesla Optimus Gen 3 and Figure 02 represent two different approaches. Yet from the perspective of deployment efficiency, Optimus is already pulling ahead. At Tesla's Gigafactory, Texas, Optimus Gen 3 has been tested directly on the production line, handling tasks such as lifting 15 to 20 kilogram components, placing them accurately onto conveyors, and inspecting product details using its sensor system. This workload is equivalent to the basic capacity of an average factory worker. One striking figure is that Gen 3 can operate continuously for 48 hours with its 3 kilowatt-hour battery, more than 5 times that of Figure 02, which lasts only around 8 to 10 hours depending on the task. Optimus Gen 2, by comparison, managed only 3 to 4 hours before needing a recharge, making it unsuitable for real production environments. The ability to expand its task range also sets Gen 3 apart. In trials, Optimus Gen 3 successfully carried out more than 30 different warehouse operations, from lifting and sorting to materials monitoring. Figure 02 so far has only announced trials in 3 to 5 basic tasks, mostly focused on lifting 5 to 10 kilogram boxes and placing them onto shelves. This multitasking advantage makes Optimus a far more practical option. Gen 3, at its early stage, could only manage 3 to 4 simple motions, such as walking, bending, or picking up light objects, clearly not comparable. Optimus Gen 3's learning speed for new tasks marks another leap forward. Internal testing reports show that Gen 3 needs only 5 to 10 minutes of direct human guidance to memorize and repeat a new job, then gradually improves with each cycle. With Figure 02, learning still depends on language-based AI systems and pre-trained models, meaning a process can take hours or even days if software adjustments are needed. This creates a major gap in adaptability. Gen 3 had virtually no fast learning capability. Teaching it a new job required engineers to reprogram the entire sequence. Teamwork is another remarkable aspect. Tesla has tested 5 Optimus Gen 3 units working together in a 2,000 square meter warehouse. The result? The robot team processed about 200 boxes in an 8-hour shift, roughly equal to the output of 6 to 8 human workers. In terms of daily life applications, Tesla aims to bring Optimus Gen 3 into households as a personal assistant. Early tests show it can organize items, perform basic cleaning, and help move heavy objects at home. With a 20-kilogram lifting capacity and 48-hour runtime, Optimus could replace much of the heavy work that elderly or disabled people cannot manage. Figure 02 has not announced any home environment trials, focusing almost exclusively on logistics. From a market standpoint, this wider application range is a huge advantage for Tesla. Sustained performance is another key benchmark. Tests indicate that Optimus Gen 3 can maintain stable performance for more than 36 hours of continuous operation without major errors. In contrast, Figure 02 in public demos usually runs only 30 to 60 minutes, with no confirmed data on long-term endurance. From the perspective of task execution, Tesla Optimus Gen 3 has clearly surpassed both Gen 2 and Figure 02. With its 20-kilogram lifting power, 48-hour battery life, ability to complete more than 30 tasks, and reliable performance across multiple work shifts, Optimus proves it is ready to move beyond the lab and into real production environments. Figure 02, meanwhile, remains stuck in the proof-of-concept stage, with limited task range, short battery life, and unproven long-term operation. The question now is not, can Tesla build an intelligent robot, but rather, how soon will Optimus Gen 3 be mass-produced in the tens of thousands to serve the market? And based on current data, Tesla is already a very long step ahead. What makes Optimus Gen 3 more affordable than Figure 02? When people think of humanoid robots, the first thought that usually comes to mind is, it must be insanely expensive. And that's true, for now. But Tesla is trying to change that. Elon Musk has emphasized that Optimus Gen 3 will be priced below $20,000. Think about it. That's the same or even less than a small Tesla electric sedan, no longer some distant, unreachable figure. So, here's the question. If you could buy either a car or a robot for the same price, a robot capable of working 24/7 in a factory or even in your home, what would you choose? Meanwhile, Figure 02 is priced at around $80,000 to $100,000. The gap is obvious. Tesla is aiming for mass adoption, while Figure is keeping its robot in the premium range, targeted mainly at corporations or research labs. Even if you run a mid-sized company, would you really spend $100,000 on a robot that is still in the testing phase? Compared to Optimus Gen 3, the difference is also striking. When Generation 3 was introduced, it was more of a showcase than a commercial product. Pricing wasn't disclosed, but it certainly wasn't anywhere near Musk's $20,000 target for Gen 4. With each generation, Tesla has not only improved Optimus's capabilities, but also driven costs down by leveraging its automotive production expertise. Gigafactories, Gigapress, and the 4680 battery supply chain give Tesla an advantage. Figure simply doesn't have, turning a prototype into an industrial product. Another key factor is return on investment. At $20,000, businesses can easily do the math. If a robot replaces 1 to 2 workers, the investment pays for itself within 1 to 2 years. But with Figure 02 costing close to $100,000, the payback period could stretch to 2 or 3 times longer. For small and mid-sized companies, that's a tough pill to swallow. That said, a higher price doesn't automatically make Figure 02 unreasonable. The company has chosen a different strategy. By charging more, Figure is targeting large enterprises, where minimizing risk, ensuring accuracy, and handling complex tasks matter more than the upfront cost. In that sense, Figure today resembles Tesla's Gen 3, focused on proving capability before scaling the market. The decisive factor, however, remains production scale. Tesla already has factories in place, meaning Optimus can share assembly lines with EVs. That's why the company is confident about the sub-$20,000 price tag. Figure, lacking this infrastructure, has no choice but to keep prices high to cover R&D and low-volume production. So who wins on price? Compared to Generation 3, it is cheaper, more practical, and closer to being within reach of everyday users. Figure 2, at $100,000, will struggle to reach a broad market. In the end, what matters isn't how smart a robot is, but how many people can afford it. And on that front, Tesla is clearly far ahead. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.